And I'm also switch off my video. And I'm sharing the screen. Yeah, can you see the screen shared? All of you?
Yes, sir. Yes, sir.
Yes, yes. Now I am writing this equation as sine theta, okay, from this equation, sine theta is equal to n by lambda into e plus d. Okay, what e plus d? I have to take it. Suppose say e is the screen width and this is the separation. Suppose say, okay, because we have said that this is the width of the slit is e, separation is d. Now this is actually e plus d. Now what it will give x plus d. Suppose say I take this as 1 centimeter. In 1 centimeter, I'll make a large number of openings and closings. Suppose say I'll take E is equal to 0.1 and D is equal to 0.1. Therefore, I'll take as 0.5 and 0.5 centimeter. That means width of the slit is 0.05 and separation between the slits is also 0.05. Then E plus D will be 0.1 centimeter. Okay, if E plus D is 0.1 centimeter, how many openings or closings are there in 1 centimeter? How can you calculate? Anyone, can you tell me? How many openings or closings are there in 1 centimeter? It is nothing but, okay, how many E plus D's are there in 1 centimeter? So E plus D is 0.1 centimeter. Therefore, I take 1 by 0.1, which I'll write it 10. So 1 centimeter by, okay, 1 by E plus D I'm taking. 1 centimeter by 1 plus D. So 1 centimeter E plus D is 0.5 centimeter. This will cancel, I'll get 10. So that means in 1 centimeter, there are 10 slits. Thereby, simply 1 plus E by D gives you number of slits that are there n. Hence, I write here sine theta is equal to, okay, 1 by E plus D means, okay, into n lambda. I write here n sine theta is equal to n into lambda, where I put 1 by E plus D, the grating element, as number of slits is equal to n is equal to number of slits, okay, per unit length. So thereby I write this formula lambda is equal to sine theta by n into n. This is the formula you have used. Okay, have you used the same formula for lasers?
Yes, sir.
Yeah, this is the, so therefore,
Yes, sir.
you, here I say lambda is the wavelength of unknown source, what you have found. But to find what you have measured, you measure theta, that is angle of diffraction, you measured it, the angle of diffraction. And you know what is small n. Small n is simply order, first order, second order, third order you have taken. In diffraction, only one grating one order you have measured. And capital N is number of slits or number of openings, okay, or number of lines we have written, number of lines, okay, per centimeter you have used it. Here they have given, of course, in inches. So thereby the question may be asked, how to determine wavelength using diffraction grating? So you take the grating equation, you solve it, and so show that lambda equal to sine theta by n into n, and by measuring, by measuring or measuring theta, angle of diffraction, from the experiment. So in both the experiment, angle of diffraction theta from the experiment, from the experiment. Theta lambda can be found. Can be found. So you have to substitute small n and capital N. By likewise, you can do it. This is called grating equation, which we have used in the earlier class. Now we solve some problems based on the equations which we have derived it. Okay. So I will go for the first problem. So make a note of first problem. The first problem is
Sir, one show the derivation. One show that again.
which one? Previous one, previous
Yes.
derivation. Yeah, yeah. Okay. So yeah, can you see this now?
Yes, sir. That last one. I'll
Yeah,
write it.
this
Yeah.
one.
Yes.
Yeah. So therefore, you should remember that 1 plus e by d gives you the number of sets, because see, 1 centimeter I have divided many so many. So 1 by that many width will give you n. Yeah, finished.
Done.
Yeah, shall I move to the next one? Yeah, this is the first problem. All of you note on the first problem. The problem is a parallel beam of wavelength lambda 5460 angstroms diffracted an angle 30 degrees. Okay. So in the problem, to know the solution, okay, I'm writing the solution here. The solution is, okay, solution I'm writing is lambda given as 5460 Armstrong units. And what else they have given? Can you tell me? Angle of diffraction. Angle of diffraction means theta they have given. Theta is equal to how much they have given? 30 degrees. Okay. So I will write lambda is equal to 5460 Armstrongs. I'm converting it to meters as 10 to the power minus 10 meters. So theta has given, lambda is given, and grating has lines. They have given lines. N they have given as 6,000 lines per centimeter. Lines per centimeter. Okay. So, but you need to convert them into meters. N they have given that many. So lines they have given. So how many lines are there per meter? Anyone can you tell me? Per meter.
60
60. 60.
per meter na sir.
Yeah. Per meter I want.
60.
That means 1 per centimeter I have 6,000. Meter is larger one, na?
6 into 10 power 5.
Yeah. Otherwise, you do one thing. If you don't want to convert this into meters, centimeters. Okay. Then I can write this is equal to 10 to the power minus 8 centimeters. And then there is no problem with this. I can continue with this. Okay. I can keep this also. And angle is even diameters, but better you convert everything into, okay. So if I want to convert this into the meters, you can write 6 into 10 to the power 5 lines per meter. Okay. And diffraction angle degrees. So degrees is in, of course, okay, as you know, it is in SI unit. Therefore, I'm using all SI units. So what is asking? Find the highest order. What is small n is asking to find out. We have now grating equation. Grating equation is lambda is equal to, we have seen sine theta by small n into capital N. So follows is asking to find n. N is equal to sine theta. Okay, sine theta given as 30 degrees by capital N is 6 into 10 to the power 5 is the small, okay, capital N they have given into lambda. Lambda they have given as 5460 into 10 to the power minus 10. Everything SI units I have taken. So if you simplify, how much you are getting? Can you tell me? What is sine 30?
1 by 2.
1 by 2. So simplify this, how much I'm getting now? 1 by, I'll get something, 2 into 6 into 5460 into 10 to the power, I have minus 5.
1.52, sir.
1 point. Sure, all of you got the same.
5.
Yeah, please check again and tell me how much you're getting. How much amount?
1.526, sir.
1.526.
1.526.
Yeah. So you're getting 1.526. But what is this? Order. Order they're asking. N. But you know, orders will be 1, 2, 3 only, not 1.5. You cannot have 1.5 order. So therefore, you should write answer as, don't truncate it to higher order. You can see only 1 or 1.5, but the 1.5 is somewhere here. I cannot see. I can see either first order, second order, third order. Therefore, n is only one order. Highest order you can see is only 1. So always when you are giving n value as something 3.2 or 3.05 or 2.99, if you are getting, write only the previous value. That is integer value only, 3 or 1. You cannot see 1.5 order. Means that you cannot see the second order also. That means you can see only first order. Therefore, always when you are doing such problems to find n value, don't write n value as 1.025 or something like this. Okay? Because order is always an integer. Either it will take a natural number 2, 3, 4, 5. Therefore, the answer will be highest order you can see with this grading is only first order. Only one order you can see. Followed all of you? Did you complete this problem? Yeah, rule number 5. Did you complete the problem? Ananya, 4.
Yes, sir.
Yeah, did you follow this? Always keep n value as lower by, don't truncate it to higher value.
Yes, sir.
Okay. So therefore, by solving by some means, if you get n value as okay, n is equal to, suppose you get 4.62. Okay, write only order is 4. If you are getting 4.999, also order 4 only. You have to write. Okay. So thereby, if you are getting 5.2 or 5.01, the fifth order can be seen. That is the value you have to answer. And go for the next question. Next question is this. See the next question. A Fraunhofer diffraction due to a single slit is observed on the screen. Place 2 centimeters away from the lens. That means I have here a single slit and I have a screen here. Okay, lens and the screen is here. So this is at 2 meters away from this. 2 meters away from this. This is a single slit. We have slit. This is lens. This is screen. So, and they are saying that the slit width is this. This slit width is 0.2 mm they have given. Okay. And first minima lie at 5 mm. That means this is the central maxima. This is the central maxima 0. Okay. First minima means either right or left. And this distance they have given as 5 mm. 5 mm they have given. Either side of the central maxima, that means first minima may be at 5 centimeters or 5 mm below this. 5 mm below this from the central maxima. This is 0 means central maxima. Okay. We have central maxima there. This central maxima. Central. So in our experiment, then is calculating what is wavelength. So what they have given now? They have given D. D is nothing but this is the D. The distance between these two is 2 meters. Okay. Then X they have given. This is the X. So X they have given from this one. Actually, this is 2X. In our laser experiment also, you have found the distance between corresponding maxima, first order, second order. So they have given X is equal to 0.2 mm, which is equal to 0.2 into 10 to the power minus 3 meter they have given. X value they have given. Okay. And what else they have given? X they have given. Now, this they have given slit width. Slit width is E. E they have given as, okay, the slit width, sorry, this is not X, sorry. X is 5 mm they have given. I have to write 5 mm, okay, not this. I should write 5 mm because lie at 5 mm, so this is 5 mm. So I should write this as 5 mm, not slit width, it is 5 mm. So I write this as 5 mm. Slit width they have given as 0.2. So 0.2 mm. So this I should write as 0.2 into 10 to the power minus 3 meters. Everything is in SI units. And they're asking to find out what is lambda. So from this diagram, they have given this distance D and they have given this distance X so that I can find this theta, sine theta. So sine theta is actually X by D. But our diffraction single slit minima condition, they're asking for minimum. Okay. For single slit minima, single slit minimum equation, we have E sine theta is equal to n lambda. This is the one. Okay. And first minima, they said first minima, n is equal to 1. First one. And E they have given. And asking to find out what is lambda. They're asking to find out what is lambda. So E they have given. E, okay, is 0.2. Sine theta is x by d. I can directly substitute x by d. Therefore, E into sine theta is x by d into n. N is 1. Lambda I want to calculate. Okay. D is this. Okay. D is the distance between these two, and x is this. X is this distance. And here is x, 2x will get. And therefore, from which I'll write lambda is equal to Ex by D. E they have given as a 0.2 into 10 to the power minus 3. X we got at a 5 into 10 to the power minus 3 by D they have given 2 meters. So what is the value of lambda? How much are you getting?
5 into 10 to the power of minus 7.
5 into
10 to the power of minus 7.
minus
7.
7, which is nothing but 5000. Okay, I'm writing Armstrong units. Can I write like that? or you're getting 5 into 10 to the power minus 5 centimeter. So you will get this answer. Okay. So did you complete this? Shall I go to the next problem? All of you, did you follow this? Shall I stop here this problem? Shall I go to the next problem?
Yes, sir.
Yeah. So next problem is in this based on the same, find the highest order of diffraction, shown by a grating having 15,000 lines per inch. Find the highest order of diffraction shown by a grating having 15,000 lines per inch for a given wavelength 5893 Armstrong units. So highest order that following for a grating. So we have grating equation. So I'm writing the solution here. What is the grating equation? Can anybody tell grating equation? I want to write the grating solution. Grating equation is lambda is equal to sine theta by n.
Sine theta by
uh,
small n.
Yeah, small n. Good. So what is asking to find out highest order? What is the highest order they want? Highest n. It can be shown, not the least one. Okay. For given lambda they have given 5893 into 10 to the power minus 8 centimeters. Then capital N, they have given 15,000 lines per inch. I'm converting this into lines per centimeter. Okay. And then they're asking to find theta, sine theta. Have they given sine theta value? Can you find the sine theta value in the formula? Anyone? Can you tell me what is the value of sine theta? They're asking to find out highest order.
1.
Yeah, 1. Good. You have to take 1. Highest order is this because highest value sine theta can take is 1 only. So for highest n, sine theta should be highest value, that is 1. That's all you can take. Okay, because sine theta n are directly proportional. If you see here, if I take n other side, okay, yeah, I can write this as n lambda is equal to sine theta. You can write. So therefore sine theta. Hence I'll write lambda is equal to, I want to find from n is equal to sine theta by capital N into lambda from this equation. I take n this side lambda will come down, will come down. So sine theta is 1, but n they have given 15,000 lines divided by 2.54 lines per centimeter into lambda is 5893 into 10 to the power minus 8. So how much is the n you are getting? Yes, Sai Saket, you unmute yourself. Can you tell me what is the value of n?
28.734.
28.
0.7.
7. So what should the value n I should take?
28.
28. Not 2.8, no, 28.7. Are you getting all of you 28.7? So n is highest order you can see is 28 orders you can see, not one or two. Many orders will be there. So for finding highest order, you should take n sin theta equal to 1. That is the highest order you can find. Okay. So you just make a note of this problem, then I will go to the next problem. Yes, shall I move to the next problem? Have you done this? Completed? Roll number 13. Have you done this? Yeah. Srivardhan 38. Have you done this experiment? The problem? Did you complete it? Roll number 5.
Yes, sir.
Yeah. Shall we go to the next problem?
Yes, sir.
Yeah. So I go for the next problem. So always you should write the below value only. You don't write these decimals. Okay. This value only you can have. Now I'll go for the next problem, Q4 question 4. Okay, this is a simple one, but another important one. So they are asking to calculate, okay, the angular separation. Calculate the angular separation. Okay, so I'll go for this here. Calculate the angular separation. Angular separation means how much is the angle difference between the given two one angular separation between the first order, okay, so calculate the angular separation between the first order minima on either side of the central maximum. Just a minute. So 1 minute, I'll close this one and I'll again come back and share the screen. Okay. There is now you see, calculate the angular separation between the first order
Sir, in
minima,
above problem, value of n is 2.8. We are getting, sir.
not 28.
Yes, sir.
Yes, sir. 2.8, sir.
So 2.8 you are getting. Then n should be written as 2 only.
Yes, sir.
Yeah, please check who has sent this. Who said this 28? You check your calculation. So you are getting only 2.8, not 28. Okay. So therefore, so shall I write as 2.8 here? 7, and therefore n should be taken as 2 only. Okay. Is it okay now? Yeah. So I'm going for the next problem. Calculate the angular separation between the first order minima, means two minima on either side of central maxima, okay, central maxima, when the slit is illuminated by a wavelength lambda is equal to, okay, by a wavelength 6 into 10 to the power minus 4 centimeter. They have given this. Okay. Okay, sorry. When the slit is illuminated, not this, yes, illuminated, I'll take this as instead 6,000 Armstrongs. When the slit is illuminated by a wavelength system, the width of the slit width is 6 into 10 to the power minus 4 centimeter. Okay, this is the given problem. Now he is asking to calculate angular separation. Means that to understand this, I have a single slit. This is the line. This is the screen I am taking. Okay, this is the 0 order, or we call it as central maximum. Now the light is getting diffracted by some angle. So I am taking that it is diffracted by some angle and giving you first minima. This is first minima. Okay, first minima. And on either side of that, we do also have first minima here. This is first minima. So this is some angle theta. By the same angle, first minimum also go on the other side. So they want to find out what is this angular separation. What is this 2 theta? They're asking to find out. How much is this? We have to find angular separation. Equation is sin theta is equal to n lambda. N they have given as a first order. Lambda they have given as a 6,000 Armstrong units. So I can write it as 6 into 10 to the power minus 8 centimeters. I take it as, okay. And then they have given slit width E is equal to 6 into 10 to the power minus 4 centimeters. And therefore we have E sin theta is equal to n lambda means that E is 6 into 10 to the power minus 4. Okay, and I want to find theta. What is the theta? I have to find first. Then you have to find the angular separation is 2 theta. So into sine theta is equal to 1 into 6000 into 10 to the power minus 8 centimeters. So if I want to simplify this, I will get sine theta value by simplifying it. Okay. So how much do you get sine theta value? So this is 6000 into 10 to the power minus 8 by 6 into 10 to the power minus 4.
0.1.
0.6.
0.1.
0.1 or 1? Okay, 0.1. Okay, 0.1. So therefore, theta is equal to sine inverse of 0.1. What is the angle? How much do you get?
5.7.
5.7 degree. Are you getting 5.7 degree, all of you?
Yes, sir.
So this is 5.7. Okay, this is 5.7. That means they're asking to either side of the central maximum. What is the angular separation? So angle separation is now angular separation. Angular separation. If I take it, separation is 2 theta. Is 2 theta. So that is 2 into 5.7 degrees. How much do you get?
11.47.
47 degrees. This is the separation between these two. Okay. And then I will give you the next problem if you could able to complete this. Do it quickly, complete this. Yeah. Have you done this? Completed? Completed this? If you have done, we will go to the next problem. Okay. On diffraction. Have you done? Completed?
Yes, sir.
Yeah. So the next problem is okay. For, so I'm writing the next problem. Okay, I'm going here. The next problem is Q5. The question is that a wavelength, a wavelength. Okay, I'll go for the. So I'm using this. A wavelength. The value they have given as 6 into 10 to the power minus 5 centimeter is incident, okay, on a grating, on a plane transmission grating, means grating only, plane transmission grating, plane transmission grating. Okay, gratings may be different type, reflection type, transmission type, but what we are discussing is only plane transmission grating. Wavelength of is incident on a plane transmission grating with 5 into 10 to the power 3, okay, lines per centimeter, lines per centimeter. Okay, then what is the highest order that can be observed? Okay, what is the highest order observed? Highest order observed. You have done this problem already, this type of it. But in addition to this, they're also asking which spectrum, which order is absent if, okay, if opaque spaces means that is D, okay, spaces are exactly 2 equal to 2 transparent places, transparent places, spaces. Spaces. This is an important question. You have to say it. You know how to find highest order. To find highest order, lambda is equal to sine theta by n into n. Okay, for highest order, I'll take it. Sine theta is equal to 1, n into 1, I'll write. So n, highest order n I have to find. N capital N they have given us 10 to the power 3 per lines. Directly I can take. Then n I'll write it as something like, okay, n I want to find it. 1 by 5 into 10 to the power 3 into lambda. They are given 6 into 10 to the power minus 5. You will get the highest order. How much you are getting highest order? Can you tell me? What is the highest order?
3.3.
3.3.
3.
So I should write n equal to
3.
3. Now, which spectra is absent? Absent means that suppose say this is the grating and you are getting this is the central one, 0th order. After 0th order, this is the first order. Okay, the first order n equal to 1, first order maximum. I'll get n equal to 1. Then I'll get n equal to 2, second order. N equal to 3, third order. So I can see many spots on it. So n equal to 2, n equal to 3, likewise. And n equal to 4 also I'll get. But he's saying that, can I see all these orders or is there any missing order which is absent? That means first order is present, second order will not be there, but higher orders like third order will be there. Fourth order may be there or may not be there. So those are called absent spectra. So therefore, you should first understand what is absent spectra. And these absent spectra is also called as missing spectra. Missing spectra. So why missing spectra is there? Okay, of grating. Why do, okay, how do I have a missing spectra for a grating? Because we have seen that there are conditions for maxima and minima for diffraction grating. Those maximum minimas, if I take it, there are two conditions. What are the condition? Maxima, central maxima condition and minima condition also there. Therefore, we have to now see simple equation for grating from the grating equation. So to see and understand this missing spectra, they may be asking us a short answer question. What is missing spectra or absent spectra? So to get this formula, the principal maximum, okay, so we have seen already the condition for principal maximum or central maximum. So principal maximum, okay, maximum condition for grating, which is called grating equation. Condition for grating is nothing but grating equation. So grating equation is E plus D sine theta is equal to n lambda. Okay. Then we have seen that here this is the maximum will occur, but minimum also will be there. Minimum, okay, minimum intensity due to single slit, due to single slit. Why single slit? You know that grating will have many single slits like this. So therefore, minimum due to any one of the single slit exactly falls on the maximum of grating. So maximum is the maximum velocity. This is the maximum one. Okay. But single slit also gives you minimum. If the single slit minimum exactly falls on this, these two intensities cancel each other. Therefore, that particular order cannot be seen, which we call it as missing spectrum. Therefore, if already maximum is there, this is the maximum. Okay, maximum value I'm getting because of the suppose say central condition, that is principal condition of grating will give you maximum, but at the same time, okay, condition for minima due to single slit is also satisfied by the same angle, then it falls on it. Therefore maxima and minima cancel each other, hence that particular order cannot be seen. That means what actually happens is that, okay, suppose say I take grating spectra. So grating spectra, if I just take the grating spectra which is formed by something like this, okay, this is the maximum and minima coming like this is a, okay, single slit. But grating maxima, okay, is there, suppose a grating maxima. So minimum of single slit exactly falling something like this. Therefore, they cancel each other. Hence, this particular order is missing. Hence, we say that whenever maxima of one falls on the minima of the other, so maxima minima cancel each other. So therefore, for certain value of grating condition, okay, minima will exact of the single slit will fall on each other. Therefore, I write minimum condition for single slit is E sin theta is equal to n lambda. So if both conditions are satisfied simultaneously, this is 1, this is 2. If both conditions are satisfied simultaneously for a given n, for a given order, for a given n. That means maybe third order of this exactly falls on second order of this, then both will cancel each other. Or fourth order of this exactly falls on second order of this, they will cancel each other for a given, okay, for a given n. If both the conditions are satisfied simultaneously for a given n, then that particular order is missing or absent. Particular order is absent, or we say missing, is missing. But if that particular order is missing, means that it does not mean that all higher orders are missing. All orders may be there. Okay. is missing. Therefore, if I say take the ratio of equation 1 and 2, if I take it, I'll get E plus D sine theta, okay, by E sine theta is equal to. So to show the difference, what is the difference? Yeah, okay, some particular value of n, second order, is falling first order of that. That means m is different from this n. Hence, in some cases, instead of writing n, they will write here as m. Okay, that means first order or third order of this exactly falls on second order of this. So here m. Okay. So thereby I write this equation as E plus D is equal to n lambda. I write n lambda and this is m lambda. So lambda lambda gets cancelled and sin theta goes away. I'll get E plus D by E is equal to n by m. The condition for, okay, the condition for missing spectrum. The condition for missing spectra or absent spectra, absent or missing spectra, missing spectra. Now go to the problem. What is asking? The problem is which order is absent if the opaque spaces are exactly equal to transparent places. You know, E is slit width. That is, okay, transparent. That is transparent. D is actually slit separation, that is opaque place separation. So this is opening E, therefore it is transparent for the light. This is D, the light will be stopped by it. This is separation. So slit separation is opaque. In the problem, what they are giving, okay, here condition is that problem, if opaque spaces D is exactly equal to two transparent places 2D, D equal to 2E, they have given here. Okay. So therefore, I have to now see that what is happening. So in the problem, they have given, okay, given that D is equal to 2E. Carefully you have to write how they are using it. Therefore, I write here in this equation E plus D by E is equal to N by M. Okay, follows E is now E, D is 2E by E is equal to N by M. Or I write here, okay, 3E by E is equal to N by M, which I'll write 3 is equal to N by M. Otherwise, I'll write, okay, N is equal to 3M. So if N equal to 3M, the maximum due to diffraction exactly falls on minimum due to single slit. They will, if therefore, N can take the values 0, 1, 2, 3. Okay. So I take integer values. I take M can take 1, 2, 3, all for possible values because it is an integer value. Since in this equation, you know that M will take the values, okay, 1, 2, 3, and so on, including 0, of course. So if I go M1, 1, then if I put M is equal to 1, okay, N is equal to 3, means third order is missing. If M is equal to 2, I'll write 2 into 2, sixth order is missing. Otherwise, N is equal to 3, I will write 3 into 3, ninth order is missing. Therefore, in this condition, okay, which order will miss? Third order will miss, sixth order will miss, ninth order will miss. They are absent. And so on, they are absent. Means that 0th order will be seen, first order will be seen, second order will be seen, but third order will not be there because the maximum minimum are falling at the same time. Okay, again fourth will be there, fifth will be there, sixth order will not be seen. Okay, and seventh, eight will be there, seven will be there, eight will be there, ninth order will not be seen. These are called missing orders in this one. Okay, so with this I stop here, and we'll solve some more problems in the next class. So meanwhile, if you have any, okay, so this is also a short question. They will ask what is absent spectra or what is missing spectra. Give the condition for missing spectra. This is absent spectra or missing spectra. So the spectrum will miss because the maximum and minimum are falling at the same location. So they cancel each other. Maximum due to the principal maximum of the grating and minimum of the single slit exactly falls, they cancel each other. Therefore, if they are canceling each other, certain orders are missing. That does not mean all others are missing. Only 1, 2, 3 orders will be there in this case, but sixth order, third order cannot be seen. Okay, it is missing. And here sixth order cannot be seen. Ninth order cannot be seen. They are missing. But all other orders are possible. So if you have any doubts in this, you can ask me now. Okay. And these problems are also important, which you have to upload in the Teams 1. Yesterday class, today's 2 classes. Yeah. Roll number 4, Ananya.
Yes, sir.
Have you done the problems?
Yes, sir.
Roll number 7.
Yes, sir.
Yeah, Kalyan, 19. Dharani, 14. Hindu, 17.